Hi, I'm Mike Stanzik, and this is Digital Electronics Classroom. In this video, we're going to be talking about 7-segment displays. Now, if you haven't watched the video on LEDs, I would highly recommend that you do that before you watch this video so that you can get some of the background of LEDs and how they're connected, and this video will make a little more sense. Okay, let's get started. So we're looking at 7-segment displays. And everybody loves acronyms, so these things are called SSDs. Okay. So first off, we have a picture of the 7-segment display shown right here. And then we also have the internals shown in this picture, the configurations. There are 2 configurations that we'll be looking at, the common cathode and the common anode, and we'll explain what that means as we go along. There's also a labeling that goes along with the 7-segment displays, and don't worry about that DP, it means decimal point, but essentially it's labeled starting from the top in a clockwise fashion, so A, B, C, D, E, F, and then the crossbar here is a G. And so that's how we label it. Now you'll see that they correspond on our other diagram here to inputs to the actual chip, to the actual device. So that's just what we're looking at, okay? So let's talk about these 2 configurations. Common cathode, what do we have here? So common means connected together, so they're sharing the same voltage, they're connected at the same point. So a common cathode means that we have all 7 of these LEDs, and you can see this in the diagram itself, but I think it's easier to just kind of look at it like this. Here's 3, 4, 5, 6, and 7. So the cathode is the part, and I'm not going to draw the little arrows that represent that it's giving off light. I'm just going to leave them like that as LEDs. Okay. And so the inputs are right here: A, B, C, D, E, F, and G. Okay. The cathode is the part of the device where positive current flows out, and so the cathode here is the part that's underneath. So these are all the cathodes. And so to have a common cathode means that all of these are connected together. And so these are connected together. There we have it. Now, the typical way that we would use common cathode is, since we want to send our positive current ultimately to ground, is we would connect this to the ground right here in our configuration. And then on the other side here are our inputs. And now these inputs, you'll notice, don't have current limiting resistors. So that's our responsibility to put external current limiting resistors on these. And a good value for that, for the current limiting resistor, is 220 ohms. And we'll look at that when we start to build these up, okay? And so then you'll have the ability to either connect 5 volts to these lines or not. And if you connect 5 volts, then this thing will turn on. And if you don't connect 5 volts to each of those inputs, then it won't turn on. And in that way, we can turn on different parts of this 7-segment display and make our alpha or numeric characters as we see fit. Okay. And so the common cathode is that you put 5 volts on the input to turn on. And we connect the common point to ground. Okay, so those are 2 of the big ideas right here. So what about the common anode? So the anode is the part where positive current flows into the device, and so that's on the top here. So in this case, we're going to make all of these again: 1, 2, 3, 4, 5, 6, and 7, and we're going to connect the top parts together. And then this will be connected to 5 volts. Okay, so that's 5 volts here. So these are all powered up and ready to go on this side. What about on the other side? Well, the other side is where we put our inputs this time. So it's almost like they're outputs, right? But we still consider them to be our inputs to our device. Okay, and so if I want to turn this on, I have to meet the threshold voltage of 1.5 volts. So I have a choice. I can put 5 volts on this, or I can put 0 volts. So this is the digital nature of it, 5 volts or 0 volts. So if I put 5 volts on this side, then the difference in voltage is 5 volts to 5 volts, it's 0. And so there is no voltage difference, and that will not turn on. But if I put 0 volts on the bottom side, then we have 5 volts to 0, and that's going to be enough to turn on the 1.5 volts. But we don't want it to be 5 volts, we want it to be 1.5, and that's where that current limiting resistor will come in, which I'll show you once we get into actually making the circuit. Okay, and so this is going to be, you connect ground to turn on, and the common to 5 volts. Okay, great. And just a note here, note that the current limiting resistances are external and need to be added. Okay, it's your responsibility. Okay. Great. So let's go ahead and switch over to Multisim Live. So this is Multisim Live. It's the online version of Multisim, and there is a free version of this. I don't know if it has all the components I'm going to use today, but if you're involved in, say, like a PLTW program, you do get access for free, and so you can ask your instructor about that, and then you can use this anywhere you have access to the web. Otherwise, you're welcome to use the full Multisim program. I'm on a Mac right now, and so the full Multisim program does not run on Mac machines. It runs on Windows machines, and so I can't use that, so I'm just using the live version. So if you're using the live version, you can follow along with me in building these. Okay, so let's go with the common cathode first. So we find these in the indicators section, and we can see 7-segment display, and I'll just go ahead and place that in the middle here. Okay. When I click on it on the right hand side, we get the choices for the configuration of the 7-segment display. And there's CA and CC. So CA is common anode, CC is common cathode, and I want to select that CC as common cathode. So in the common cathode, the common port, which is shown right here, is connected to ground. And so I'm going to put a ground here, and then I'll go ahead and connect the common port, wiring it up. Oops. There we go. Wiring it up to the ground. Okay, so there we have it. Now on these A through G, these are the inputs that control all of these LEDs. And so we need two things. Well, first off, we need an input that we can switch between 0 and 5 volts. And then we need a current limiting resistor. So let's go ahead and do that. So down here at the bottom are digital circuits, and there's a digital constant. And this is what we're going to use for our input. So I'll have a digital constant right there. This switches between 1 and 0, which switches between the voltages that are defined for 1 and 0. Now, over on the right here, this is set into CMOS mode, and so it's 3.3 volts. So I'm going to override that and put it to 5 volts, and so we'll see that performance a little bit better as we look at both this and the common anode. Okay. Now we're going to put a resistor in here, and I'm going to put that resistor right in front of it, and then it says 1K, and I'm going to change that value here to 220, so 220 ohms, and we'll connect this together. All right, so let's just do a couple of these, and so, oops, I'm just going to go ahead and duplicate this, and then duplicate this one. Go ahead and duplicate again. Great. Okay, so I could do all of them, but at this point, I think I'm just going to show you a few of them connected like this. So we'll do A, B, and C. Okay, great. So now I have a digital constant connected. It's going to be 5 volts when it's a 1, and it's going to be 0 volts when it's a 0. And this is common cathode, so to turn on the LED, we need 5 volts. We also have a 220 ohm current limiter, which should limit us to about 16 milliamps, and that's inappropriate in the range we're looking for. Up in the top left here is a play button that says, hey, let's start it up. And there we have it. We have a 7. Perfect. 7 for all 3 of these turned on. So now if I want to change that top one, A, I would just click this and it goes to a 0, and you can see it goes off. It goes off right there. So we can make a 1 and we can make a 7 by clicking on those different ones right there. So that's the common cathode configuration. So let's go ahead and stop this. You can't make any changes while you are active. So we'll go ahead and stop it there. So now I'm going to put in another 7-segment display. And we'll make this one a common anode. And so a common anode is going to need a connection to 5 volts. Let's see if there's a digital 5 volts. You know what I'm going to do? I'm going to cheat. I'm going to take this digital constant here, make sure it's set up for 5 volts, and I'm going to leave it as a 1. And then that will be connected here. That'll be a 5 volts signal. So I changed it to 5 volts here, and then I left it as a 1, so it's connected at 5 volts. And I'm also going to reuse these guys. So I'll just disconnect each of these, and then connect them over here. And this time let's see, with 3 you don't have a lot of options, but let's do these later ones. Let's do E, F, and G. Okay, great. So same configuration now, but we should see the opposite performance. So when there are 1s here, we can see that the LEDs are off. Because this is common anode, we have 5 volts connected on the anode side, and so if we want there to be a change in voltage, we want to have this be low. We want this to be ground side. So if I turn this to ground, what we'll see is that the LED does turn on. And so that one is E, that one is F, and that one is G. So we have like a sideways T, or a part of an H, or a part of an F, and so that's how it goes. Okay, well, thanks a lot for watching. I hope you enjoyed this. I hope you found value from it. That's 7-segment displays, common anode and common cathode. I'm Mike Stanzik, and this is Digital Electronics Classroom. Until next time, have a wonderful day.